interact with the device. And one of the limitations was kind of goes off the very last point I talked about, that the experience of participants with fingerprint sensors was different. And as I mentioned earlier, interaction and habituation has an impact on how well do users, or not how well, but what kind of fingerprint images do users provide to the system. So this was an important limitation, and we tried to control this by allowing all users to have a practice session with it. So in terms of the variables that were collected for the study, collected the demographics of the participants, age, gender, and their ethnicity, and what would they say is a wear and tear on their finger. Their own subjective criteria was used. We collected the fingerprint images from the 9 different sensors and collected the finger skin characteristics like I mentioned earlier. Some of the important variables that were controlled during the data collection, we controlled the lighting level. Lighting has an effect on optical sensors because of the underlying technology. So we tried to simulate lighting that would happen in an office, a controlled environment. The temperature and the relative humidity also have an impact on the type of fingerprints that you provide to the system. So again, those were controlled in specifications with office environment conditions. And the sensor surface was cleaned before the start of each individual session. This was done to ensure that there was no residue or no remnants left behind from the previous subject, so that when an individual provided their fingerprint on the sensor, you would not get any kind of an underlying reflection effect from the previous interaction. I don't know how. Okay, that came up better than I expected. So the data collection protocol, just to step you through it pretty quickly, the subjects were introduced to the study. Then we had to go through some ceremonial process of introducing to the study. We also have to comply with the ethics board, because this is human data. So we had to get their consent. And once all the administrative work was done, the users got to interact with the device in a randomized order. So no two subjects interacted with the devices in the same order. This was done to actually control what is called the learning effect. And as users interact with the devices, if they interact with the devices in the same order, you'll see that they end up providing better images towards the end of the study. So this was done to control and minimize that effect. Then before they interacted with each sensor, their finger skin characteristics were measured. We also collected the force, how much force was applied on the fingerprint sensor when they interacted, and we collected 6 fingerprint images from a particular sensor. The first 3 images were separated into an enrollment data set. The last 3 images were separated into what was called a test data set. And then the user basically repeated that entire process until they were done with all the 9 sensors. So in the end, I collected data from 190 subjects. There were 9 sensors, and on each sensor they provided 6 images. So in total we had 10,260 fingerprint images at the end of the study. And the entire data collection time period was about 3 months, 3 full months of data collection before we could actually go ahead and do the data analysis. This is just a photograph of the setup. Towards the left, you see all the 9 sensors that were used, and on the right, you see the fingerprint sensor that was placed on the force plate. And in the center of the force plate, you'll see a Velcro strip. This was done so that the user could place the fingerprint sensor on the force plate, so that, and when they interacted, it wouldn't move. So this was to fix the sensor to the force plate. Just a description of the participants. There were a total of 190, and the male and female breakdown wasn't equal, but 131 subjects were male, 59 were female. And since data collection happened here on Purdue campus, you can expect most of the participants to be under the age of 30 years, which was what was noticed. And predominantly, everyone was right-handed. Again, fingerprints from all the subjects were collected from their dominant hand only. So that was again done to control the difference in interaction between subjects if only their right hand or their left hand had been specified. So now going into the data analysis methodology, there were three main components. The first one was looking at the minutia count analysis. The second looked at the image quality analysis, and the third was the false non-match rate analysis. So for the minutia count analysis, we use a commercially available software, and the hypothesis that was tested was that minutia count for the data sets collected using these 9 sensors was statistically similar. That was a null hypothesis, and the alternate hypothesis was that the minutia count for the 9 different data sets was not similar. Here I have the minutia count tabulated. You can see data set S1 had a minutia count, average minutia count of 72, and data set S5 had the lowest minutia count, which was 29.16. So here itself, you can notice quite a range in the differences in minutia count for data sets that were collected from the very same individual, but the only difference was that they were collected on different sensors. A parametric F-test was performed to actually test the hypothesis, and with the results, we concluded that we rejected the null hypothesis, and we concluded that the minutia count for the data sets was actually different between these nine different data sets. So the parametric F-test told us that these 9 different data sets were not similar in its minutia count, but it did not really identify which pairs of data sets were actually not similar. So basically a full pairwise comparison was performed. And the way to interpret this table is if the value is less than 0.05, then that particular pair was not statistically similar in its minutia count. And if the value is greater than 0.05, then the pair being compared is actually statistically similar in its minutia count. So what you see here there were 3 pairs, S3 and S4, S2 and S7, and S6 and S9, that were actually statistically similar in its minutia count. And out of these, only S3 and S4 were of the same type. All the other pairs were actually collected from sensors that were of different technology types. So the next step performed was a very similar methodology, but here we looked at the image quality of the data sets, and the idea was to see if the mean image quality scores for these 9 different data sets, are they statistically similar or not. And again, looking at this table of the average image quality scores, you can see data set S1 had the lowest image quality score, and data set S5 actually had the highest image quality score. If you actually relate this back to the minutia count table, S1 actually had the highest minutia count, and S5 had the lowest minutia count. So there's obviously some kind of relation between minutia count and image quality going on. Again, with the parametric F-test that we did on the entire data set, we concluded that the image quality scores were in fact different between all the 9 data sets. So the next step was to actually drill down and see which pairs of these data sets were statistically similar and which ones were not similar. The way to interpret this table is exactly the same. The numbers that are greater than 0.05, those pairs were statistically similar.